Hello and welcome to the 2024 Winter Weather Refresher put together and presented by the Denver Center Weather Service Unit. Throughout the course of this presentation, we're going to be talking a bit more about the winter season hazards that we'll see as we go through the next several months. During the summertime, it's a lot of emphasis on convection and the hazards related to that. But as we head into winter, we do see an increase in the number of weather hazards, as well as an increase in the number of incidents and accidents related to such hazards. First and foremost, we're going to start by talking about turbulence and wind shear. Now, turbulence and wind shear can, of course, occur throughout the entire year, but it does increase as we head into the winter seasons, both in intensity and duration. Now, when we talk about turbulence in the summer convective season, we're usually referring to turbulence in or around convective clouds. However, as we head into the winter season, turbulence can occur with or without the presence of clouds. An example of that would be clear air turbulence. Now, we typically talk about turbulence at two different levels. High-level turbulence, turbulence found above flight level 180. It's typically associated with strong jet stream winds, merging jet streams, curvatures in the jet streams, or breaking mountain waves. Low turbulence, turbulence typically occurring below flight level 180, is typically associated with strong cold fronts or most commonly strong flow over rough terrain. The image on the right is an example of that. As winds blow from left to right on that image there, it impacts the mountains, gets forced up and then back down, and then you have a whole mess of air moving in all directions, which can result in that low-level turbulence. And here's a look at the different turbulence intensity from moderate, severe to extreme. Remember, as a controller, you are required to solicit PIREPs in the presence of moderate turbulence or greater, or the forecast of moderate turbulence or greater. Moderate turbulence usually results in changes in altitude and attitude, but the aircraft remains in control. There normally is some variation in the indicated airspeed. As we get to severe turbulence, large abrupt changes in altitude or attitude can occur, variations in indicated airspeed, and the aircraft may be momentarily out of control. When we get to extreme, it's normally reserved for cases where one of the following three can occur. Aircraft is impossible to control, there's damage to the aircraft, or there are injuries reported. So it's possible severe turbulence may result in injury, which would upgrade our turbulence event to extreme. Now, moving on from regular turbulence and wind shear to mountain waves, something that is, of course, very common here in Denver Center. Now, the biggest difference between mountain wave and typical high-level turbulence is there's a lot more impact in the vertical as opposed to the horizontal. This often causes significant up and down drafts and changes in indicated airspeed. Quickly looking at the image on the right there, you can see the wind flowing from left to right across the image. As the wind hits the mountains, it's forced up and then sinks on the other side, sending out a ripple hundreds of miles downstream from the mountains. And as the airplanes incorporate these ripples, they impact those updrafts and downdrafts, resulting in the mountain wave turbulence. Now, severe turbulence would likely be downwind of the mountains, not necessarily over them themselves. And as mentioned, they can extend hundreds of miles downstream from the mountains and may extend vertically from near the mountaintops all the way up to flight level 450 and even above in some cases. Now, the two biggest mountain wave hotspots we see across our airspace occur across southern ZDV, and that is the San Luis Valley surrounding Alamosa. As the winds blow from west to east across that area, mountain wave turbulence can occur over Alamosa itself or even further downwind towards Trinidad and towards that Oklahoma and Texas Panhandle area. Now, closer to Denver, of course, we have the Colorado Front Range. Winds flowing from west to east across that range will result in mountain wave turbulence from around Denver, even as far out as Goodland in Kansas. Mountain wave turbulence, here's another example of a picture there of some severe cases. That is, as the wind blows from left to right across the image there, it encounters a very stable layer of air over the mountains. When that happens, it's forced down in a braking action similar to how a wave would break in the ocean. Now, in this example, the severe to extreme turbulence would occur in the circled area there as those waves break. Strong updrafts, large net altitude changes, strong downsloping winds can occur, resulting in low turbulence, as well as dangerous low-level rotor clouds. Here's an example we like to use here at Denver Center all the way back from 1992. This was a Douglas DC-8 cargo aircraft that lost its #1 engine and 19 feet of leading edge of left wing. Light to occasional moderate shock preceded severe clear air turbulence as it flew over the mountains. Now, mountain waves themselves aren't necessarily forecasted by the Aviation Weather Center, meaning that there won't be any air mets issued for those. Now, in the case of mountain wave activity, CWSUs will issue meteorological impact statements for planning outlooks. If we know there's going to be mountain wave activity in the days to come, we can send out that impact statement to make you all more aware. We'll also then issue center weather advisories to emphasize ongoing or high probability forecasts of significant mountain wave activity. So instead of seeing an AirMet, you may see a center weather advisory that reads pretty similarly to the AirMet, just kind of highlighting more of the potential for mountain wave as opposed to regular clear air turbulence. Now here in Denver Center, we use kind of an approximate severe intensity threshold. Anything greater than or equal to 600 feet per minute updrafts or downdrafts, greater than or equal to 25 knots of speed change, or greater than or equal to 1,000 feet of altitude change. Any of those three would mean that this is a severe mountain wave event. Now, moving on from turbulence, we're going to start to talk a little bit more about icing. Icing, again, like turbulence, can occur year-round, but of course is much more common here in the winter seasons. Icing, as we know, can form on the surface of the airframe, forms on the exterior instrumentation, forms also inside the air intakes of the engine. Now, regardless of the type, icing can significantly impact aircraft performance. Exposure time is critical, of course, because icing only occurs in icing conditions. In the event of any aircraft emergencies, you can seek the assistance from the Center Weather Service unit to help mitigate the impacts there, or just simply get the airplane out of the icing conditions. And here is a look at the different icing intensities from trace all the way to severe. As a controller, you are of course required to solicit PIREPs for the presence of light icing or forecasted light icing, which of course is different from turbulence, where moderate or greater is required in solicitation. Now, trace icing is perceptible, but no significant accumulations are occurring on the airframe. In light icing events, significant accumulation for a prolonged flight is possible, greater than 1 hour. As we get into moderate icing, significant accumulation for shorter periods of flights, and then in severe icing scenarios, rapid dangerous accumulations can occur in even less than a minute in some cases. And here's an example of a severe icing event from inside our airspace. This was November 6, 2019, where this was a severe icing event out of Metro, BJC there, accumulated several inches of ice in just a few minutes and had to do an emergency landing back at Metro, which resulted in a hard landing and damage to the aircraft. And here are some things to consider about aircraft icing. Most people would assume that icing can occur in any temperature below freezing, but that is not necessarily the case. Let's look at the picture on the right, showing the vertical profile of a cloud with different temperatures. Now, on the bottom end of that picture, temperatures are above freezing, meaning there's water droplets present, but there is no threat for icing because temperatures are above freezing. It's the layer that's just below that that is actually the most significant for icing. That is, temperatures typically around -3 degrees Celsius or -10 degrees Celsius. That is because in this range, liquid water droplets can exist in below freezing temperatures. It's not until those liquid water droplets hit an aircraft that they begin to freeze on contact, resulting in what could be significant clear icing. Now, as we get in temperatures colder than that, the layer above that on the image, from -10 to about -20, we have a mix of supercooled droplets as well as snowflakes present. That, of course, can result in rime icing or mixed icing. Now, what most people don't know is that temperatures colder than -20 degrees Celsius, typically we're just talking about ice crystals. Ice crystals are a lot less sticky than both liquid cooled water and snowflakes, and accumulation is a lot less. So again, when we're talking about temperatures, it's that -3 to -10 degrees range. That is the most significant for icing, but of course can occur in temperatures as cold as -20 degrees. Now, some mitigations for icing. As mentioned, the best mitigation is to simply get out of the icing conditions. When we're talking about the potential for clear icing, that typically occurs in cumulus clouds. The best thing to do is, if an aircraft encounters that, is to simply get out of the clouds. Now, in stratiform clouds, they can cover pretty much the entire area, so it's a little bit harder to get out of those. The best mitigation strategy there would be to change altitude to get into either warmer or colder temperatures. Of course, the first priority would be to ascend to warmer temperatures to get out of the conditions completely, but that's not always the case or possible due to MEAs. It is possible to, of course, climb into colder temperatures, colder than minus 20 degrees Celsius, to get out of the most significant icing conditions. Now, moving on from icing, we're going to talk about a relatively new weather type of hazard as we head into the winter season, and that would be snow squalls. The definition for a snow squall is as follows. They're intense but limited duration periods of moderate to heavy snowfall, accompanied by gusty surface winds resulting in reduced visibilities and whiteout conditions. Rapidly falling temperatures in conjunction with the snow can cause dangerous impacts to surface. So we're going over that definition. A couple things pop out. Intense but limited duration, so it is a short-term event, and periods of moderate to heavy snowfall. In all intents and purposes, this is essentially a thunderstorm, but snow. As just mentioned, a snow squall warning is similar to a winter severe thunderstorm warning. It's a short duration product that focuses on distinct areas that are expecting potentially deadly winter weather. It can happen at Denver International Airport as well as any of our airports within the airspace. Most recently it occurred at Denver February 27th of 2024. Here's an image on the right that shows kind of the precipitation, how it looked on radar moving through the area. What happened is that the winds began to pick up. The snow began to fall very heavily, reducing the visibility and RVRs, and the snow accumulated very quickly, resulting in poor to nil braking action, which essentially shut down the airport for a short period of time. Now here's a video that shows what a snow squall could look like. This was over Steamboat Springs, Colorado. And again, it almost moves the way a thunderstorm would. In fact, in this case, there was lightning present in this. So as you can see, you can go from pretty much VFR conditions and no significant weather at an airport to low IFR conditions and potentially a shutoff in just the matter of minutes. Now, aside from turbulence and icing, there are other winter season hazards that we encounter most often as we now head into the next several months. For one, widespread areas of IMC, including IFR to low IFR, are a lot more common. Mountain obscuration, dense fog, and freezing drizzle can all occur. We have snow and blowing snow that can reduce visibilities and RVRs at any airport. Low altimeter values are something that occurs a lot more common into winter times, as well as strong gate level winds and compression. Strong surface winds are more common outside of thunderstorms and may result in low level wind shear. All of these hazards can, of course, impact airports in many different ways. It can result in ground delay programs, ground stops, runway closures, de-icing operations, and or just reduced arrival rates in any capacity. In the winter time, we do see an increase in strong mid to upper level winds, which, as we talked about, can result in more turbulence, but the winds themselves can have an impact on aircraft operations as well. Strong or shifting winds can impact maneuvering of traffic in several ways. For one, airlines want to take advantage of strong tailwinds and avoid strong headwinds. This will impact routing all across the area, resulting in monitor alert issues. The time and space required for ascent, descent turns can be impacted. That can result in compression. It can also result in, as mentioned, higher volume in traffic and within the favored sectors. Again, typically we might see an increase in traffic where there are strong tailwinds or a decrease in traffic over certain areas where there are headwinds. Now let's talk about PIREPs. As you know, you are required to solicit PIREPs for effective areas when one or the more following weather conditions exist, are reported, or forecast to occur. Ceilings at or below 5,000 feet, visibility reported on the surface or loft at 5 miles or less, thunderstorms and related phenomenon, turbulence, including mountain wave of moderate degree or greater, icing of light degree or greater, wind shear, volcanic ash clouds are reported or forecast. Now also during emergency situations and or for specific weather needs and events. Why is this important? Of course, PIREPs are used by us to assess current conditions for advisory issuance and adjustments and to assess computer model performance. Some important reminders about PIREPs. PIREPs should provide clear distinction between clear air turbulence and mountain wave activity. The way to do that, in mountain wave events, they should always contain the speed and altitude changes. When talking about icing, it's important to always include the temperature in Celsius with all the icing reports. Here's a couple examples of some PIREPs on the right hand of your screen there. This first one is showing mountain wave activity with a speed and altitude change of 80 feet and 10 knots respectively. As we see, there's that mountain wave distinction in the remarks there showing the speed and altitude change. And here's another example of severe mountain wave that occurred over Alamosa from a 757. 2,000 feet per minute updrafts and downdrafts with plus or minus 35 knots in speed change. An aircraft loss of 1,000 feet and unable to control the aircraft. So that is a very good example there of severe mountain wave activity. During aircraft emergencies, weather situational awareness is critical. Knowledge of PIREP and weather advisories, of course. And don't forget, you may always contact the CWSU desk when you need assistance during an aircraft emergency. An example would be a VFR stuck in a cloud layer. We can help vector out the aircraft to VFR conditions or advise on how we can either ascend or climb the aircraft to get out of that layer. Providing immediate assistance during aircraft emergencies is actually our top priority here at the Center Weather Service Unit and why the unit was created in the first place. Now, as a controller, you will come across many different weather products, and you may not know the difference between all of them. In order from most important to least important is here. SIGMETs are the most important product, and they are issued by the Aviation Weather Center in Kansas City. AirMets are also issued by the Aviation Weather Center in Kansas City, and that is more for conditions favorable for hazardous weather to occur. Center weather advisories are issued by us, the CWSUs, and add information to existing SIGMETs and or AirMets. Meteorological impact statements may go out days in advance, issued by us, mainly when impactful mountain wave activity is anticipated. Now, SIGMETs are, of course, the most significant advisory issued by the Aviation Weather Center. They are only issued when significant meteorological conditions are occurring or expected to occur shortly. And examples for SIGMETs would be for severe or greater turbulence, severe icing, widespread dust storms, widespread sandstorms, or volcanic ash clouds. They are typically valid for 4 hours and may be preceded by or augmented by center weather advisories. An example on the right is a SIGMET for severe turbulence. SIGMET Yankee, valid for 4 hours. Occasional severe turbulence possible from the surface to flight level 180. And sort of the next step down from SIGMETs are our AirMets, and those are issued as more advisory products. Ceilings of less than 1,000 feet and or visibility less than 3 statute miles. Widespread mountain obscuration, moderate turbulence, sustained surface winds greater than 30 knots, or moderate icing. That is an important distinction there. As mentioned, you are required to solicit PIREPs if light icing is forecasted to occur. During an icing AirMet, it is expected that moderate icing or greater can occur. So you may be encountering light icing and required to solicit PIREPs even if there is no icing AirMet available. AirMets are typically issued every 6 hours, but they can be updated as required. Now, center weather advisories are, of course, issued by us at the Center Weather Service Unit. They can read similar to both a SIGMET or an AirMet and can be used to just augment the information that is within one of those. Or a smaller scale CWA can be issued in areas where an AirMet or SIGMET doesn't actually exist, but those conditions are occurring. Again, issued by a ZDV Center Weather Service Unit meteorologist. Example, I may issue a CWA. It may or may not precede or augment a SIGMET, and they are issued for conditions that would result in SIGMETs or AirMets where coverage isn't there. We typically issue these for 1 to 2 hours and update every 1 to 2 hours as needed. Issued incrementally for each new hazard area and subsequently for each update of hazard. That means for the first CWA of the day, we will issue CWA 101. As those conditions continue, we'll update to 102, 103, 104, etc. However, if we issue a new CWA for a different type of hazard, we will start at 201 and go on from there. Meteorological impact statements aren't used quite as often, but they are mostly used for planning purposes for significant mountain wave activity here at Denver Center. If we look at the data and think that there is a significant mountain wave event occurring in the next couple of days, we can issue a meteorological impact statement to just get the word out. Here's an example of an MIS one of us issued during a mountain wave activity. Again, reads fairly similar to how an AirMet or SIGMET would look, just with some more supplemental information. Now, as a controller, you will have a lot of pertinent weather information available to you, including those in SIGMETs, AirMets, CWAs, and PIREPs. Remember to solicit PIREPs aggressively, especially when those aviation weather hazards are present and or forecast. Not only do they help the pilots out, but they help us out as well. You can always give us a call at the CWSU if you need help or have any questions. If you are within Denver Center, that's extension 4251. If you are outside of Denver Center, it is the Denver Center number with, of course, the extension of 4251. On behalf of the entire Denver Center Weather Service Unit, I want to thank you for taking the time to watch this winter weather refresher. And again, if you have any questions, please feel free to reach out.